This is a servo motor. They are used in many different applications like RC cars, robotic arms, or wherever you need precise rotation control. But how do they work, and how do we use them? A servo motor is a DC motor with a gear train attached, and it's connected internally to a small circuit board. The gear train is a set of gears connected to each other and have the job of converting the high-speed, low-torque input into a low-speed, high-torque output. The circuit board is what drives the motor itself. It takes the signal input, does calculations, and determines the current angle position of the motor and if and where the motor should rotate. But how does the motor know its absolute and relative position? The solution to this problem is simple but genius. In electronics, there is such a component that outputs a value based on how much it is turned, the potentiometer. As you might know, a potentiometer is a variable resistor that changes its resistance as we turn it to the right or to the left. But how do we use this value that is expressed in ohms into a value that the motor driver can comprehend? We use a so-called voltage divider. Placing a voltage across the potentiometer, we get in return a new voltage value based on how the potentiometer splits its internal resistance, and thus based on its position. When the potentiometer, and so the servo arm, is rotated all the way to the left, the resistance between the positive rail and the wiper will be zero, and so we read the full voltage. When the potentiometer is rotated all the way to the right, the resistance will be maximum, usually in 10 kΩ, and we will read 0 volts. With half rotation, we will read half the voltage, and so on. Now we know how the servo takes the control signal and acts accordingly. But what signal does the motor take? A servo motor needs a very specific type of signal called PWM, or pulse width modulation. PWM is a fancy term for rapidly switching on and off a voltage signal. A servo doesn't really use PWM in the classic sense, where what counts is the ratio between the on-time and pulse duration, also called duty cycle. Instead, it reads the width of a pulse to determine the target angle. To control this servo motor, we need to send a pulse for a certain period of time every 20 milliseconds. The time duration of the on pulse can be from 1 to 2 milliseconds long, with 1 millisecond indicating 0 degrees, and 2 milliseconds indicating the maximum angle the servo is capable of. So how do we actually control servo motors? A servo motor has 3 wires, a brown one for the ground, a red one for power, and an orange one for the control signal. Let's start wiring everything. We will power the servo motor directly from the Arduino. Because the SG90 typically draws 10 mA when stationary and 100 to 250 mA when moving under no load, it is crucial to connect it to an Arduino pin that can provide this type of current. The analog and digital pins are a no-go, as they provide a maximum of 20 mA. We need to use the 5V output pin that can provide 500 to 800 mA based on the circuit power supply. So let's connect the red wire to the 5V pin through a red jumper wire. Then we need to connect the ground pin to one of the ground pins of the Arduino. Let's choose the one next to the 5V pin. And finally, we have the signal pin. We can connect it to one of the pins that are capable of generating a PWM signal, the ones with the tilde sign. Let's choose pin number 9. Now this is where you can get creative. You can just write code to control yourself the position of the servo and create a sequence of movements, or you can move the servo according to some kind of sensor, like a distance sensor, or external input, a potentiometer or a joystick for example. I'll use a potentiometer. To do so, you need to make very simple modifications to what we just connected. Disconnect the red jumper wire and connect it to the positive rail of the breadboard, as I do here. Then grab a black wire and connect one end to the negative rail of the breadboard and the other to one ground pin of the Arduino. At this point, everything should look like this. Now we need to place the potentiometer on the breadboard so that it goes across this groove right here. We are almost done. Connect one of these 2 legs of the potentiometer to the 5V rail and the other to the ground rail. Then we need to connect the output leg of the potentiometer to an analog pin. I'll choose pin A0. All that is left to do is to give the servo power. Connect the power pin of the servo to the 5V rail, and we are done with our connections. Here is a schematic of the circuit, both with and without the potentiometer, in case you missed anything. Now we have a look at the coding part. Open the Arduino IDE, and before the setup function, type this line of code. This tells the Arduino IDE that we will be using commands from the servo library. Then we need to create what's called an object. We do this by typing servo and then the name of the object. I'll choose servo1. We also need to define a pin constant to keep the code tidy. We chose pin number 9 for the servo signal. Now we need to type this. This binds the servo object we created to the signal pin we chose. Finally, we can write in the loop function the movements we want the servo motor to make. To do so, use this command, where we need to specify the angle where we want the servo to move to. To make the Arduino wait between commands, you can use the delay function, where you need to specify the amount of time you want to wait in milliseconds. This code, for example, makes the servo rotate 10 degrees to the right, then waits a second, and then rotates 10 degrees to the left, waits another second, and starts the whole sequence again. If you want to push things further and use a potentiometer to control the movement, we first need to choose a pin to read the voltage outputted by the potentiometer. Since this is an input analog value, we need an analog input pin, and we need to declare it as such. We chose pin A0, so we need to write this before the setup function to give it a name. Then, to read the voltage values across the potentiometer, we need to use this command. This tells the Arduino that on the pin we chose we are receiving continuous data and stores it in a variable. The Arduino will take these values and convert them into a range from 0 to 1023. Since the servo motor wants to know the angle it has to move to and doesn't understand the value the Arduino provides, we need to translate them into a value that the servo will understand. We do this with this command. This matches the Arduino values with angles. You can play around with this line of code and change it so that if the potentiometer is turned all the way to the right, the servo moves, for example, to 90 degrees by changing this number right here. If you also want to see how this conversion takes place, you can write these numbers in the serial monitor as a final touch. All you need to do is write in the setup function this line of code. This will activate the serial communication of the Arduino. And then, to write the values, you just need to use the serial print function. In the last line of code, we use the serial print ln function, so that the Arduino puts a blank line and separates each block of data. Use the command we saw earlier to move the servo motor by putting the angle variable between parentheses. All that is left to do is connect the Arduino and upload the code. If for some reason you are seeing these strange symbols in the serial monitor, check that this number and this number are the same. And now you can control your servo motor with a potentiometer. That's all for this video. I hope you learned something new today. If you enjoyed it, leave a like and consider subscribing. You can find more videos and tutorials on screen right now. Thanks for watching, and I'll see you in the next one.